Hello. Today we'll talk about functional foods. So what are functional foods? And the common definition is that functional foods are foods that have a positive effect on health beyond basic nutrition. They can be whole, fortified, enriched, or enhanced through breeding of plants, which are the sources of functional foods, for example. Whole foods would be like your blueberries, recently claimed to be very beneficial because of their very high antioxidant content. Oatmeal, because of soluble fiber, which has been scientifically proven to lower cholesterol. Fortified foods can be orange juice fortified with calcium for bone health, and you're allowed to put that claim on the package because it has been substantiated scientifically, or milk fortified with vitamin D, for example. Enriched, for example, gold potatoes enriched in anthocyanins and carotenoids, naturally, again, through breeding. You probably also have heard of golden rice, which have been enriched in vitamin A-like carotenoids using biotechnology. So those all are examples of functional foods. However, there is no legal definition of functional food. So consumers have to decide on their own what is and what is not functional food. And what can truly help them in doing so is reading the label. We already talked about nutritional facts label on the back of every package sold in the United States by law. And it is a very good idea to study this very carefully and then possibly evaluate certain claims which are on the package through Googling it or talking to your physician. And often, if you have certain disorder, a doctor will suggest that you eat certain foods which clearly can be functional in this particular case. So functional foods, many of which have functional health claims on the packages, are around you now all the time. So how did that come into being? And of course, the history of agriculture started about 10,000 years ago when people started to get settled in small settlements and develop fields around the settlements and start growing crops in those fields. And of course, for the most of the agricultural evolution of our society, the main goal of agriculture was just to grow enough calories to sustain a certain level of nutrition, to prevent people from malnutrition and from starvation. That was the goal, just grow calories. Much later on, when breeding became quite prominent, sometimes around 16th, 17th, 18th century, people started breeding crops for taste, particularly fruits and vegetables. People wanted them to taste better, particularly rich people who could afford those better varieties. Then vitamins, essential minerals were discovered in the beginning of 20th century. And we started to understand nutrition much more. So we started paying much more attention to, for example, vitamin content in certain food. And that vitamin content would add functionality to them and then could be put on the label. People started paying attention to them. We didn't know about vitamins before, 100 years ago, actually, almost to the day. And of course, today, in the last 15, 20 years, at least in the US, you start seeing those health claims on the packages of foods. And we've discussed that in the labeling of foods and labeling of dietary supplements. So I'm not going to get into this. How do those claims actually get on those packages? But by law, if you put any claim which makes that food functional and relates it to human health, for example, healthy heart, lowers the cholesterol, by law, such claim has to be heavily and rigorously substantiated through clinical trials, human clinical trials, which will actually show that the statement is true. Any other notation is illegal unless it's scientifically proven. A breeding of functionality into foods have been going in two directions, actually. Firstly, breeders try to increase the concentration of compounds
which are believed to be beneficial, which is shown to the left of this table. For example, capsaicin in peppers, although it doesn't taste well, but it's a powerful anti-inflammatory agent. Flavonoids in grapes, menthol and peppermints, lycopene, there are very high lycopene tomato varieties now, lycopene, carotenoids, which have beneficial antioxidant effects on the body, and so forth. But also, the unhealthy compounds have been bred out of many plants. For example, cyanogenic glucosides, which are toxic, have been bred out of some cassava variety, which now have a small amount of them. And there are many other examples of unpleasantly tasting compounds or actually toxic compounds which have been removed from certain crops. You can see the list on the table to the right actually comes from the publication which we've done a while ago. It's cited on the bottom of that slide. I would like to give you an example of some superfoods which have been recently developed in our laboratory at Rutgers University. We tried to improve the nutritional health benefits of lettuces. And through several years of research, initially led by Dr. Pogrebnyak, we were able to develop special varieties of what we call Rutgers super lettuces or Rutgers scarlet lettuces, which have 3 times the antioxidants of the gold standard of functional foods, which is blueberries. And we've done that through tissue culture, breeding, and selection. We actually took lettuces which already have high levels of antioxidant polyphenols, like anthocyanins, reduced them to individual cells, and they've done extensive selection on individual cells of lettuces, and then regenerated the cells which had highest amount of antioxidant compounds in them into lettuces. So it's not a GMO type crop. It's not a genetic engineering which we use. We used just selection, except we did it not in the field, but in a tissue culture. And the resulting varieties are now entering the stores in the United States. You see 2 examples also shown on this slide. They are sold under superleaf lettuce label. The global market for functional foods is growing rapidly and will likely continue to grow and expand. And in 2018, it was close to $160 billion in US dollars, with a healthy growth rate of about 8%. If you look at different components of the functional food market shown on the diagram below, it's dietary fiber, foods enriched, fortified in dietary fiber, vitamins, minerals like iron, like calcium, carotenoids, again, antioxidants, fatty acids, omega-3 fatty acids certainly have been drawing a lot of attention recently in their cardiovascular benefits, prebiotics and probiotics, foods which are enriched in bacteria, beneficial microorganisms like lactobacteria, like live culture yogurts, for example, or probiotics. Those are probiotics and prebiotics, actually foods which can modify your gut microbiome, can modify your gut microflora in a way which improves your health, and then many others. So what kind of health claims can you put on the package of the functional food? And this is very much regulated in the US, at least by FDA. And the claims that you're allowed to put on your package have to be rigorously proven through clinical trials and scientific research. And FDA has to approve those claims. You cannot just say that something is good for your health unless it has been rigorously proven and approved by FDA. We've discussed that in previous lectures. So the approved claims are, for example, calcium and osteoporosis. We know that consuming foods enriched in calcium will improve joint health and bone health. Also, reducing the amount of sodium in foods will lower the risk of hypertension. Saturated fat is also negatively correlated with heart health. it can lead to cardiovascular diseases, for example. High lipid level can lead to cancer. Eating fruits and vegetables may actually reduce the risk of cancer. You're allowed to state that. For example, it is well known that pregnant mothers require a substantial amount of folic acid to prevent neural tube defects in the embryos, which is a very serious malformation. And foods are often fortified by folic acid, or women are encouraged to take folic acid supplements to prevent a neural tube defect. There's a lot about claims, and a lot of research have been done about soluble fiber and cardiovascular diseases again, and you can relate now foods with high levels of soluble fiber, relate them to the reduced risk of cardiovascular diseases, and can put that on the package. So what is the future of functional foods? And I believe that this future is very bright, not only for functional foods which you can pick up from the shelves of your supermarket, but for what is called personalized nutrition. This more scientific area of functional foods, which addresses the needs of each of us as individuals. It is well known that there are differences by chemistry, metabolism, genetics, gut microbiota among all people, and those differences actually contribute to the differences in our response to nutrition. Also, genetically, some of us are more predisposed to certain chronic diseases than others, and we have much higher risk of developing those diseases than others, and that risk now can be assessed through sequencing of our genomes. So this is personalized nutrition is the way how we can truly eat correctly to specifically address certain disorders which we're likely to develop, for example, in 20, 30, 50 years when we're getting old. If the analysis of our microbiota shows that we have certain issues, or our genetic analysis, or some biochemical markers in our blood. And now, it's actually a number of companies which are starting up, and some of them are quite developed, which will look at you as an individual and suggest specific nutritional regimen, certain foods which will benefit you, for example, more than the others, based on your genetic composition, based on your biochemistry, history, and so forth. There's just minimal personalization, which you fill out a questionnaire, and then the company will suggest certain foods for you to eat. And then there's really a maximum personalization, companies which will actually sequence your genome, for example, spit in a test tube, and they look at all the potential genetic mutations and issues which you may have. For example, the risk of certain cancers. And they will either send you or again give you a certain advice on how you should eat to minimize the risk of certain genetic disorder which you might develop in the future. Botanical dietary supplements is another good way to address personalized nutrition for the prevention of diseases, because botanical supplements, by definition, are taking as a supplement to your diet, and some of them may have properties which can prevent certain diseases to which you are, as an individual, maybe particularly prone to. They don't require complete diet change, and it's a very difficult thing to actually make each of us to change our diets. This has been very, very difficult, despite the fact that we know that some unhealthy foods which we like may make us sick, and yet we continue eating them. So dietary supplements taken in addition to or on top of that can potentially be a good solution and deliver phytochemicals in a concentrated forms, which can be beneficial for us as individuals. Of course, the problem with personalized nutrition and, for example, dietary supplements taken on top of that is that to prove that they are actually efficacious in preventing certain diseases which can occur 20 years down the road, that proof is very difficult to obtain.
it is very difficult to do any kind of serious clinical trials on prevention of the diseases just because they take so long and they're very expensive. So we rely primarily on the epidemiological studies, studies of taking histories of people, going backwards, seeing what people ate and what that specific diet which they ate, what they led to as far as their health or the diseases they develop. But it's very difficult to do a clinical trial on prevention of the disease many years down the road. And this is a challenge for us to develop methodology. It's a big challenge in this area of functional food, is to develop a methodology which actually can allow us to validate the preventative benefits of foods or dietary supplements.